All right, so we start today a new chapter. So we're gonna start talking about kinematics. So this is important, but it's not the most important chapter for this class. It's the following one. So let's see. So kinematics. Let's call this one maybe planar kinematics. Okay, so first thing, that should help, huh? Is that better? All right. So planar kinematics, yes.
Planar or
Planar, yeah, Planar. Planar kinematics. So basically, planar means what? On a plane. And a plane is what? Okay, flat, but basically is two-dimensional, no? Okay, so basically it means on a plane, you're absolutely right. But if it's on a plane, is two-dimensional. So basically, is good, means that we probably, I mean, not 100%, but let's say 99.9 or 99% will be 2D problems instead of 3D problems, okay? And then the term kinematics means what?
motion.
Study of the motion, but basically means that the fundamental equations we're going to be using all the time are going to be A equals dv dt and V equal, you want to use dr dt or ds dt?
Yes.
S? Okay, so then everything will change, but ds dt. Okay. Okay, so that's basically what this chapter means. Okay, so something that we have talked about it before is that if we want to study the motion of a particle, a rigid body, an object, whatever you want, we can, in most cases, break the motion into what? Into translation plus rotation. So for example, you have this marker can be moving just in translation, just rotation, or a combination of both, no? Yeah. But basically, you can always break it into two. Okay, so this equation over here, maybe I should add one stuff. Let it put here little bars. This equation here is a vector equation. So generally, so before deriving, what do we need to define then? What do we need to define? I'm helping you over here. We need to define a coordinate system where we can apply this, no? Okay, so since we're talking about 2D, that probably means that we only need a 2D reference frame or 2D coordinate system. Okay, so we define our coordinate system. And here, just for simplicity, let me just define an object over here. Okay, where we'll have here the CG will be here at point B. So let's say I call the CG point B, and let's say we look at the motion of one point at the edge of the body or the object. So basically, we don't know if this object is moving in translation, rotation, or a combination of both, okay? So, but we know that we want to define the motion of this from this coordinate system. So what are the choices that we have? We can write a vector here as B, but we can also write a vector here as A. But what could we have as well? We could write here this vector over here as S of A to respect to B. So let me write this stuff over here. S A bar B means, so S, let's say S will be our position vector. I think the book uses R, but since we define here S, I use S. So this is the position of A with respect to B, or some people sometimes say position. What do you think they say? Instead of with respect. Relative to B. Okay, but let's use with respect, okay? I'd rather use this one over here. The other one is okay, but. Okay, and S of A, I'm gonna add one more thing here. S of A with respect to B mathematically is equal to what? S of A minus S of B, okay? Yes.
If you have S B over A or A over B, does that just change the direction of the vector? Or does that not matter?
It changes the direction of the vector.
Okay.
Yeah. It will, you will see as soon as we derive the equation, you're gonna see it, okay? Maybe not today, but yeah, it does matter. Okay, so basically, I wrote this, but really what I wanted to say is that by using vector algebra, you can go from point O to point A directly using S of A, or you could do what? You can go to point A from point O, you do S of B plus S of A with respect to B. Okay, so if you look at it, that might be the reason, okay, for the vector summation. So it would change. All right. Okay, so now that we know the position of the object and that we define a coordinate system, we can maybe deal with the velocity. So what is the equation that we are allowed to use for the velocity? Okay, so we can say, instead of Vs, we say, what is the velocity? We try to find the velocity of point O. So let's say Va will be equal to what? dSA dt, or could be equal to what?
SB plus SAB.
Correct. So now let's think about it, because try to think about what we said at the beginning, is that this object can be moving in translation, can be moving just in rotation, or can be moving in a combination of both, no? So when we derive the expression for the velocity, how many components should we have? Two, one for the translation, one for the rotation. Okay? Okay, so we do this. This is going to give us what? dsB dt plus d of S of A with respect to B dt. So what is the SB dt? Will be velocity of B with respect to B. And this could be what? Velocity of A with respect to B. Okay? Or let me just put over here this VA equal to VB over velocity of A with respect to B. Okay, now we just discussed that we should have two components, one defining the translation, another one defining the rotation. So let's start by the second one. What type of motion? So these two objects are, if you want, not the same object, no? So what type of motion can A have with respect to B?
Rotational.
Just rotation, because if this is A, this is B, they will all will be moving at the same translation, no? So the only different type motion they have can be rotation, correct? So by induction, if you want, or by common sense, we can say that this term will be defining the rotation, and that the first term over here will be defining the translation. Okay. But let's try to be a little bit more detailed. Okay, so for an object slash, if you want, particle moving in rotation. So let's have here okay, when something is moving in rotation, what do you know about the velocity? It's going to be tangent to this line over here, no? Yeah. So this point over here really is what? This should be point A, and really I call this one, but this should be point B, no? Really. The one in the middle. So really this vector here is what? S of A with respect to B, no? Now, if this is rotating with what? With some angular velocity. Correct? So the angular velocity, this one will be, if you want, coming in or out the page, no? This is rotating, correct? Goes in or out the page, no? This is rotating about the z-axis, no? Yeah. So what do you know about the cross product? A cross B will be equal to C. What do you know about C? Normal. Is it normal? It should be perpendicular to the other two. Yes? So if you think about it, this vector here is in this direction, no? This vector here is in this direction, correct? And VAB is what? Is perpendicular to the other two, no? Okay, so really what we can write over here is that VAB is equal, and you have studied this, would be omega cross of A with respect to B, no? Omega is in the K direction. So if you think about it, this is K. This could be, I mean, yeah, I'm gonna say, okay, let's see, let's do it mentally. If instead of doing it at an angle, I would have done this going, the VAB going straight up, what would you have? Omega will be on the K, correct? The velocity will be, the position vector will be, if I do it right here, will be on the, I mean, let's do it if you want. Let's say here, so let's say over here, let's say I put this one here. Let's say I do this way, the velocity. So velocity of A with respect to B would be in what direction? Only on the I direction, no? Yeah. Velocity of B with respect to B, maybe we should not put the equal sign. Maybe let me put something like this. And then this one, if you want, would be, I don't know, to do this sign over here. Okay, I'm doing something horrible here. Forget about this. I want to say that this will be on the J direction. This will be only on the I direction. Okay. And now the omega should be coming in what direction? Okay. So let's say that makes sense. So if we do K, so if we do omega cross S of A with respect to B, this will give you what? K cross what? I, and this is equal to what? Is equal to J. If you remember, the little circle. Now over here you have I, J, K. No? I cross J gives K, no? K cross I gives J, no? Yep. So basically, the important thing is that we can rewrite the relative the velocity as being omega cross S of A with respect to B. Okay? So let's say, therefore, the equation that we had before, VA equals VB plus velocity of A with respect to B, becomes what? VA equals to VB plus omega cross S of A with respect to B. Where VA is the total velocity. What is VB? Translational velocity due to translation. And what is omega cross S of A with respect to B, which was V of A with respect to B? What is that one? Rotational velocity. Okay, so the math is working, no? It's giving us one component for the rotation, one component for the translation. So after we find the velocity, what can we do? We can find the acceleration. And what is the kinematic relation that we can use in order to find the acceleration? Acceleration of A will be derivative of A with respect to T, no? Do we know what VA is? We just calculated VA, so it will be VB plus omega cross S of A with respect to B. Okay, now, before we start, now that we talk about translation, how many components would this equation, how many equations this equation should have? If you remember, we don't do the math in order to verify the physics, no? Or to verify nature. Generally, you observe stuff in nature and you try to find with the mathematical model that is called physics, no? Okay, so what do you observe when an object is moving in rotation for the accelerations? For example, again, so you need acceleration due to translation, acceleration due to rotation. So if you move in translation, how many accelerations can you have? What are the two types of motions that you can have? Either you accelerate or you decelerate, no? Correct? Now, what about rotation?
You have a clockwise or counterclockwise.
Okay, but that's fine. It's one way or the other, but what is the other one? If you have, let's say, a knot attached to a string and you turn it around, what's happening to the knot?
Tangential and centripetal.
Correct. So in other words, if you cut the string, it's gonna move tangential, but there is tension on the string because of what? Or the normal or the centripetal acceleration. So basically, from this equation, we should expect how many terms then? Wait, how many do we need for translation? One, because only positive and negative, acceleration or deceleration. How many do we need for rotation? Two. So how many terms are we expecting? Three. Okay, so good. At least we know 3 for now. Now, the other thing is that if we do the derivative of A, let's say instead of A, UV derivative, it would be equal to what? U prime V plus UV prime in mathematics, no? Okay, so let's use that concept over here. So over here, if I do this derivative, what are we gonna get? dVB dt plus what? Let's do now that UV. So we can do what? D omega dt cross S of A with respect to B plus what? Omega cross ds of A with respect to B dt. Okay, I'm not going to ask you for the derivations, okay? But this expression here, this one, I mean, you're going to memorize it. I have no doubt, okay? We're going to use it so much that you're going to memorize it. Okay, now let's look at this one. What is the physical meaning of dVB dt? Acceleration of B. What is d omega dt? Beta?
Alpha.
Alpha. So you have alpha equal d omega dt. And alpha is what is alpha? The angular acceleration, correct. I'm going to rewrite this on the next page, but teaching is repeating over and over. So this would be alpha. And now this one is going to look really ugly at the beginning, but then it's going to become easier. What is this term over here? What is ds? What is dA with respect to B dt? VAB, correct? But what is VAB? Okay, yes, but is VAB is omega cross S of A with respect to B. So really this is gonna give us here one equation, which is acceleration of A equal acceleration of B plus alpha cross S of A with respect to B plus omega cross S of A with respect to B. So when we say that we needed three terms, no? One term for translation, one term for rotation, and two terms for rotation. The two terms for rotation are tangential and centripetal or normal acceleration. Okay, so let me go to the next page and let's write this stuff. So let me just rewrite the same equation, acceleration of A equal acceleration of B plus alpha cross S of A with respect to B plus omega cross S of A with respect to B. Okay, so what do you think is acceleration of A? Okay, translation, perfect. So this is the one due to translation. Then for the rotation, we have two components. So we know these two components will be for rotation. Now you have 50% chance. One of these ones is the tangential, the other one is the normal or centripetal. So which one do you think is the tangential?
The alpha cross SA.
Okay, this one, if you think about it, is the same as the velocity, no? Alpha is coming from this one. This should be the perpendicular to the other two, no? So this should be here the tangential. Acceleration, and this one here will be what? I like to call it the normal to opposite to tangential. I think it's easier to remember tangential normal, but if you want to call it centripetal, it's correct as well. Okay, so let me do a figure so we can visualize a little bit of this stuff. So let's say, let me try to do it easy this time. Let's say this is point B, point A. I'm just going to do the translational components. So we say that, so let's say this is omega and alpha. Oh, here we need to be careful. Okay. So let's say this is rotating counterclockwise. So what could be here? What should be this component over here? This should be the tangential component, which would be equal to what? Alpha cross S of A with respect to B. Correct? Now, what would be this one over here? What would be this? Okay, this distance over here, this is what is this vector here? We need to be careful here. So then what would you have over here? Then the other one is the centripetal, no? Or the normal. So what is this component over here? This is the centripetal, and this vector here is still, and this is still S of A with respect to B, no? Okay, I know you know this, but let's write it down. Some convention for omega and alpha. So we know alpha. So what do we have? Counterclockwise, or we can have it clockwise. So counterclockwise is what? Positive or negative? Positive. Counterclockwise is negative, no? Okay. And let's write it down over here. So alpha is the tangential acceleration. What is omega? Angular velocity. Sorry, this is the angular, not tangential, angular acceleration and angular velocity. I was thinking so much about the tangential, but angular acceleration, angular velocity, sorry. Okay, so this equation here is 3D. Okay, so over here, let's try to simplify this term over here for 2 dimensions. So let's say for planar motion, basically means 2D. What do we have? Omega is only going to be about which axis? About this page. If this circle is rotating, it would be rotating about which axis? About the Z. So if you want, will be 0, 0 here, omega. We only have a component on the K. And here will be 0, 0, alpha, no? Just on the K, correct? Just rotating about this axis, no? Now, S of A with respect to B, we only have component in what? It's on the page.
Okay.
So, I mean, no, it will have X, Y, but it will not have K, no? Correct? X and Y. Does that make sense? Okay, so now let's do the operation. Let's do omega cross S of A with respect to B. That's another thing that people complain that you don't know how to do a cross product. You're gonna learn quick. You know how to do it, but you're gonna do it at least 200 in this class or more. So over here, how do you do this cross product? Even if you don't know now, it doesn't matter. I know you know, but if you don't practice it, you forget about it. So the way there's different ways to do it, I think this is the easiest way. So what are you gonna put over here? What are you gonna post on the second line? You're gonna put what? 0, 0, omega, no? And then on this one, you're gonna put X, Y, and 0. So I'm not too concerned to give too much detail, but now what are you gonna get over here? How do you do? You cross this one over here, no? You do 0 times 0 minus omega times y. Okay, so it should be minus y omega. Correct? What will be the next one? You cross this one, but you have a minus sign before that, no? So what will you have? You have 0 times 0 minus omega times x, but it's a minus before that. So what are you gonna get? X omega, and then the last one would be 0, 0. Okay, so now I do this cross product over here. I, J, K. What am I gonna get over here? What do I need to do here? 0, 0, omega, no? What will I have on the last row? Minus y omega, x omega, and 0. Yep.
For the SAB,
S A relative to B,
um,
or S of A respect to B.
in the example shown, it's only going in the vertical direction. Is it
Okay.
X and Y because it has potential to go?
Look at this figure.
Okay,
Okay.
so it's just kind of a count, even though in the other.
I
example, it's
mean,
not.
the reason here that I did it only in this direction is because we could do the omega cross S. Okay. But this is the general case, okay?
Okay.
You have X and Y components. All right. Okay, so now if I do this one, this is going to be equal to what? So it should be page 1, 2, 3. So this should be equal to what? So this is going to tell us that omega cross S of A with respect to B is equal to what? I do the same thing again. I cross this one, 0 times 0 minus X omega squared. Now do the same thing for this one, but remember there's a minus sign already outside. So it will be 0 times 0 minus, so it will be omega squared y, and there's another minus outside. So there's 3 minus, no? So it should give you what? Minus y omega squared and 0. Okay, let me rewrite this as minus omega squared x, y, and 0. What is this? Look at the previous page. Look at your notes on the previous page. I mean, previous page or up the page.
S A with respect to B.
S of A with respect to B, no? So basically at the end, we can conclude then that omega cross S of A with respect to D equal to minus omega squared S of A with respect to B. for planar or two-dimension motion, no? Yeah, so this should be for 2D. So the planar 2D acceleration equation becomes what? Acceleration of A equals acceleration of B plus alpha cross S of A with respect to B minus omega squared S of A with respect to B. Since you asked before to know which one goes on top, A or B, okay, it's always the one that goes outside. You see, A will be on top, no? If you put B, then will be B with respect to A. Okay, so I know we wrote this again, but teaching is repeating over and over. What is this component over here? Translation, what is this one over here? Tangential. What is this one over here? The normal or centripetal, but I like to call it normal. The reason I like to call it normal is because it's easier to remember tangential to normal, no? Than centripetal. And these two components basically are due to what? Rotation. So we're gonna stay here for a little bit doing problems about this, but in real life, there's two more components than that. Okay, but we are not there yet, okay? Let's first work with these ones. So let's do some examples, whatever, yeah. Oh. Okay, before we do that, let's look at a procedure on how to solve the problems. Okay, so before all you do the figure, but step one, start from a point where the velocity slash, depending on the problem we are solving, acceleration is known. Okay, this maybe does not make sense now, but as soon as we do an example, we'll do it. Find common points. So basically it means links connecting the bodies. Three, find the velocity slash acceleration of the common points from two different locations. So basically, I'm going to do a small figure now, and 4 will be to solve, okay? But basically, let me give you a very quick here figure example. I don't know if that would be the one we do or not, but I mean, this one looks like 3D, but I don't want to do it 3D, okay? But doesn't matter. So let's say this is A, B, and C. Oh, that was the problem. So in other words, do we know the velocity and acceleration of point A and B? They are not moving, no? Okay, what is the common point or the one that links those two bodies?
C.
C. Can we find the velocity of point C from point A? By using this equation. By using this equation. Yes, we can, no? Yeah. Can we find the velocity of point C from point B? Yes. So then you find the velocity of point C from point A to point B and you equate. And you see what happens, okay? And then you solve. Right? So, okay, let's see. We have time to do. We have half an hour. Great. So, we can do one example. And maybe we stop it over here. So let's find an example. I mean, I have one over here, but it's long. I have one over here with me, so, and I have the results, so it's good. Generally, I like to do generally from scratch, so that way you see how I do it, but the first one, let's just do it, then the other ones we make new problems. So this will be problem 1796. Okay, so this problem looks like this. Is that one long? Yeah, it's pretty long. All right, so but okay, so we have one bar over here. That is connected to a bar over here. And this bar over here is connected to another bar. So let's see, this will be point A, point B, point C, point D. All right, the distance over here is 2. Then the distance from here to here is 1. 1. From A to C is 1. And from C to D is 2. So they give us, they say that omega AB and alpha AB are known. So omega AB is 4 radians per second. And alpha AB is minus 6 radians second square. Okay, and over here, I'm going to do it over here, but we use the normal reference frame X and Y, okay? So what do we need to do over here? We need to find the angular velocity of the bar BC, the angular acceleration of the bar BC, the angular velocity of the bar CD, and the angular acceleration of the bar CD. Okay, let me know when you're done copying this. This is not difficult, okay? I mean, first time I look difficult, but you do good on this, Charlie. Okay, so what would be the strategy? Do we know everything about bar A? We know the angular velocities, no? We know the position. So basically, we can calculate the acceleration of point B. We can calculate the velocity of point B and the acceleration of point B from point A. Everything is known. Now, the unknowns are over here and over here. So what is the strategy? What is the common point between these two links? C. So we can find the velocity of point C from point B. We can find the velocity of point C from point D. We equate those two equations. We're going to be able to solve for omega BC and omega CD. Next thing, we're going to do exactly the same thing, but instead of finding the velocity, we're going to be finding what? The acceleration of point C from point B, the acceleration of point C from point D. We equate, we're going to be able to find the angular accelerations. Okay? So let's go for the velocities first. So, all right. Velocity of B from point A. So now remember, will be equal to what? VA plus omega cross what? S of what? What is the trick that I gave you? Which one goes first?
B.
The one that is on the outside. So B with respect to A. Correct? Okay. What is the velocity of point A? 0. It's spin, no? So if you look at it, this bar is only moving in what? Rotation, no? So if I do the cross product, it will be IJK. What is omega IB? Is it given to us? 4. Now, what is the position of B with respect to A? 2, 0, 0. That's not too complicated, no? That's why I know that you're going to be doing cross products like crazy. So, well, now think about it. You can do the cross product, but try to double check. If this is moving, the velocity of point B should be only in what direction? Just on the J, no? So let's see what the math is going to give us. What should be the X? 0 times 0 times 0 times 0, no? What would be the J? 0 minus, so what will it give you?
Positive.
0.8. Does it make sense that it's positive 8? It should be going up, no? Now I keep this in 2D because we said that it's in 2D, no? I'm not going to put the third one. Okay, now that I know VB, what can I do? I can find the velocity of which point?
Point C.
Point C. So what will be the equation? VC will be equal to what? VB plus what? So this will be, let me write over here omega BC. Make sure you put here omega BC. No, that you know, sorry, omega AB. Sorry for that. This is the angular velocity of the bar AB, no? Now, this will be what? VB plus the angular velocity of which bar?
BC.
BC cross, then this one will be S of what?
C over B.
C with respect to B. Perfect. So what is VB? Okay. Yes, if you want, or 0.8. Okay. Plus IJK. Okay. Do we know omega BC? No, it doesn't matter, but just write it down. Okay. Omega BC. Now, do we know the position of C with respect to B? Position of C with respect to B.
-1. Yes.
-1 would be the X, correct? Yes? -1, what would be the Y? Position of C with respect to B, yes, -1 and 0. So now this will give us what? 0.8 plus what? Uh, 0, this minus, no? So this one is changed, and this one will be unchanged. I mean, I've done it enough times, okay? I know If you want, you can do it, but basically the X switches sign, the Y is not gonna switch signs. After you do it for a while, you realize that stuff, okay? Okay, so we have this. So basically this is gonna give us what? VC will be equal to what? Omega BC 8 minus omega BC. Equation 1. What is the next thing we should do? What do we say on the procedure? What should we do next? To do what? No. We haven't found omega BC yet. So what do we need to do? Read. What did I say before? Okay, but we need to find what? The velocity of one point for two different locations. So what would be the other location? VC from where? From D, no? So what would be the equation? VD plus omega of which bar?
DC.
DC or CD? It doesn't matter. DC, CD is the same, no? Cross what? S of what? C with respect to D. Okay. As before, what will be VD? 0. Perfect. So we're gonna get over here what? I, JK. I mean, you see that today you're already doing a bunch of cross products, no? And we're not even done yet. So, okay, this will be what? Do we know omega CD? No. So we put here omega CD. Next, what is the position of C with respect to D? Negative what? Position of C with respect to D. Negative 2, 1, 0. So this is going to give us what? Velocity, second expression for the velocity of C will be equal to what? I'll let you do it, okay? Don't copy it. Try to do it in your head. Okay, you need to know how to do the cross product. It's not, I mean, you're going to learn, so I have no doubt. So we're going to be doing so many. So now, what do we need to do according to the procedure? Why did we do this? Now we can equate these two equations, no? Yeah, so. Equating 1 and 2, what do we get? Omega BC equal to minus omega CD. And then I get 8 minus omega BC equal to minus 2 omega CD. So you can solve this any way you want, but probably the fastest way would be to do what? If you add them together, what do you get? 8 equal to minus 3 omega CD. So you're going to get that omega CD is equal to what? Minus 8/3 radians per second. And then what can we say? And we know that omega BC is equal to what? Minus omega CD, so will be equal to what? Eight-thirds of radians per second. Okay, let's use common sense. Does that make sense that if I push over here, this one over here. So you see this one goes, I mean, for me goes counterclockwise. So for you it's going counterclockwise, no? If this one is moving this way, this one can only move on the opposite direction, no? So when you have two links together, if one is moving clockwise, the other one must move counterclockwise. Does that make sense? Okay. Is what the math is telling us, but it's what you see in red line. Okay, so now let's see if we have time. What do we need to do? Exactly the same steps, but for the acceleration. Yes.
I see that second page, yeah, sure.
So here we go. We're gonna do acceleration of what? Acceleration of B with respect to A. So we're gonna have acceleration of A plus alpha of which bar? The bar AB, no? Yeah. Cross what? B with respect to A minus omega of AB S of B with respect to A. A is the pin. So what should be the acceleration of A? 0. Here we go. More cross product. So we do this cross product. So we're gonna get here equals 0 plus I JK 0, 0 alpha AB. Oh, we know alpha AB. What is alpha AB? Let me put over here -6. And now you can look actually, oops, my lines are not straight at all. You can look at before. What was B with respect to A? 2, 0, 0. Minus omega AB was what? 4 square of 2 and 0. Okay, so if we do this calculation, what do we get? What would be the tangential? Would be, if you think about it, the tangential should only have a component on what direction? On the y, no? And that's what the math is going to give you. So the x is 0, 0. And this should give you -12. Yes, 0, -12. And then we're going to have here one component on the x plus, but let me plus. What are we going to have over here? -32, 0, no? So basically from here, we're going to get that the acceleration of B is equal to what? -32 minus 12. I need this figure. So, okay. Next, what do we do? Now that we know the acceleration of B, what can we do? We need to find the acceleration of C from point B and point D. Okay, so let's first find the acceleration of point C from point, acceleration of C from point B. The acceleration of C, acceleration of B, plus alpha of what? Of the bar BC, S of what? CB minus omega of which bar? BC, perfect. S of C with respect to B. I mean, you see that you are dealing with this bar, no? Okay. All right, so here we go. What is the acceleration of AB? We just found that one. -32 minus 12. Plus IJK. We don't know alpha BC, but if you look from before, I know I'm going a bit fast because I want to finish it. What is the position of C with respect to B? You can just look at the velocities. What was the position of C with respect to B on the velocities? -1, -1, 0, no? I mean, just be smart. You already did this. Minus omega BC. So here we go. It's going to become complicated with the math, but I think I have the result. So this should be what over here? 8/3 squared times what? I mean, this is not going to be that complicated. -1, -1. So this is gonna give minus 32 minus 12. What are we gonna get on this one? This time I'll wait for you. I don't want to do it too fast. Plus or minus? Plus, correct? And then we said this one switches sign, the other one, the Y is not gonna switch signs, okay? That's the way I do it all the time. Okay, the truth is because I know this one will be equal to what? Plus. Can somebody do this value here?
64.
Okay, so 64 divided by 9, no? 64. Let's keep it that way. And 64 divided by 9. Okay, so I have here some values. So if you do the math, this is going to give you that the first expression for the acceleration of C is equal to alpha BC minus 24.9. But starting next on Thursday, we pick up problems that I don't have the solutions, and I want you to do the calculations in class, okay? To practice. Minus 24.9, and the second one would be minus alpha BC minus 4.89. How did we call it before the equation? Okay, so it should be our equation 3. Okay, now what do we need to do? We need to find the acceleration of point C from where? D. Perfect. So try to write down the equation on your own. We find the acceleration of C from point D. So we have acceleration of D, the transitional component, plus alpha of which bar? CD cross S of C with respect to D minus omega squared CD S of C with respect to D. This is my last page over here. So what is the acceleration of D? Okay, because it's spin, no? Okay, it's not always going to be 0, but for now it's 0. So it's going to be 0 plus IJK 0, 0 alpha CD. And from before, what is S with respect to D? I have it here, negative 2, 1, 0, no? Okay, minus omega, I think was the same as the other one, which is 8/3. Negative 8/3, no? Square of negative 2, 1. Okay, so this is going to give us what? This one, let's see, by now you know. Is the X going to switch signs or not? Yes. Is the one that switch signs.
Yes, it is.
Minus alpha CD. So now this is the one. Is the Y component going to switch signs? No, I told you one is going to switch, the other one is not going to switch. So if this one was the one switching, the other one is not going to switch, no? Minus 2 alpha CD. And this one we say was going to be equal to what? So it would be plus minus what? 120. What was this one? 64. So minus 128 over 9.
Positive.
Yes, positive, correct. And this one would be the negative, minus 64 over 9. So this, I think I told you this time, I think I have the numerical application. Generally, I don't have them because I like to do the problems from 0 with you, but I don't know if I have it. Okay, it's not here at least. No, I don't have it. So this will give you what? Minus alpha CD. How much is 128 divided by 9? 14.2, okay. And minus 64 will be then 7.1. Should be half, no?
Yeah.
Okay. Again, I don't have the results, so you don't have to do it. What is the final thing we need to do? So let's see. Oh no, I have the values. Okay, so actually I have a little bit more detail. This is 14.26. Now that I found it. And the one is minus 7.13, obviously half of it. So we're gonna get then alpha BC minus 24.9 equal to minus alpha CD plus 14.26. And then what was the other one? We had minus alpha BC minus 4.89. Is that what we had before?
Yes.
Okay. Because I'm kind of copying, be honest with you. Equal to minus, oh, this one is here, minus 2 alpha CD minus 7.113. So over here again, if we want to make it fast, what can we do? If we add, we find minus 29.79 equal to minus 3 alpha CD plus 7 point, is it 63 or 53? I don't know. Yeah, 7.13, yeah, it's alpha. So basically this is gonna give us the alpha CD will be equal to 12.3 radian second square. And alpha BC from this equation should be equal to what? Minus alpha CD plus 14.26 plus 24.9. This will give you an alpha BC of 26.8. My last page. Radians per second squared, correct. Okay, this is not that bad, no? No, this part you do okay, Johnny. So, all right, so that will be it.